Good day everyone, good day ma'am. My name is BLESSY ATIS Ilajas from BSEE 1A, and for today's video, I will be going to explain on what I have learned from the lecture 6 fluid dynamics, since ang mga problem set given is kanang kuan naman kanang nanabi tayo solution. So ang ako lang is pag-explain kung giunsa pagkuha or ang akong nasabtan. So problem set number 1, what is fluid? So since this is my answer, what is fluid? For me, fluids are any liquids, gases, or basically any materials that when under stress undergo a continuously change in shape and are unable to resist tangential or shearing forces at rest. When a material is exposed to shear stress, these constant and unchangeable changes in position of one component relative to another is what makes a fluid a fluid. As opposed to this, the shearing forces within an elastic solid that has been twisted or flexed are retained. The solid will not flow and can return to its former shape, although compression is maintained. Neither the forces within the fluid nor those between the fluid and the container are shear forces. Therefore, compressed fluids can also return to their original shape. Everywhere perpendicular to the surfaces of the container, the fluid applies an outward pressure known as hydrostatic pressure. So let's proceed to the problem set number 2. Example 4.1 on page 693 to 694. What force must a dam withstand? Consider the pressure and force acting on a dam retaining a reservoir of water on figure 14.7. Suppose the dam is 500 meter wide and the water is 80.0 meter deep at the dam, as illustrated below. A. What is the average pressure in the dam due to the water? B. Calculate the force exerted against the dam. So duha tong gipangita ang average pressure and the force exerted against the dam. So these are the given from the problem set. So the height of the water or the dam is 80.0 meter deep at the dam. Then ang length is equals to 500 meter wide at the dam. So and then letter P, or the density of the water, is equals to 10 raised to the power of 3 kilogram over meter cube. And then ang atong constant value sa gravity is equals to 9.81 meter per second squared. So ang solution, so since ang atong letter A is gipangita ang average pressure, so we need to use this equation or the formula. So average pressure is equals to H over 2 Pg, or the density and the gravity. So since given naman, so ato siya i-substitute ang atong height is 80.0 meters, so kana siya, then over 2, then ang atong density, which is kaning P, is 10 cube kilogram over meter cube, times dayon sa ang atong gravity, constant value of gravity is 9.81 meter per second squared. So i-kuan na siya, simplify, then siya 80.0 meter over 2 is equals to 40, then ano siya, copy lang dayon, then simplify, 3 is equals to 3.92 times 10 raised to the 5th power Newton over meter squared. Then muna na siya, we get the average pressure, which is equals to 392 kilopascal. So since duha man gipangita diri na pud sa letter B. So ang sa letter B is gipangita is ang force exerted against the dam. So since so to find the force, we must use this formula, the average pressure times the cross-sectional area. So since nakita naman nato ang value sa average pressure, so first pangitaon sa nato ang cross-sectional area. So diri sa taon na before ta mo arrive ay mo kuan dire mo proceed. So dire pangitaon sa nato ang cross sectional area. So, cross-sectional area is equals to h times length. So, since given naman atong height o atong length, so kana siya 80. So, i-substitute lang 80.0 meter times 500 meter. Dayon, ano din, times lang dayon. So, 4.00 times 10 raised to the 4th power meter squared. So, nakita na tong cross-sectional area. Then, makaproceed na dayon ta sa force exerted dire na formula. So, since nakita na nato ang average pressure, so ato lang i-substitute kani siya 3.92 times 10 to the 5th power Newton per meter squared. Dayon ang ato ding cross-sectional area kani so 4.00 times 10 raised to the 4th power meter squared. Then times lang dayon. So now we can now arrive the force exerted against the dam, in which is equals to 1.57 times 10 to the 10th power Newton. So therefore, these are the average pressure, 392 kilopascal, and the force exerted against the dam is equals to 1.57 times 10 raised to the 10th power Newton. So let's proceed to the problem set number 3. Example 14.3 on page 705 to 707. Calculating force on wheel cylinders. Pascal puts on the brakes. Consider the automobile hydraulic system shown in figure 14.18. Suppose a force of 100 Newton is applied to the brake pedal, which acts on the pedal cylinder, acting as a master cylinder through a lever. A force of 500 Newton is exerted on the pedal cylinder. Pressure created in the pedal cylinder is transmitted to the four-wheel cylinders. The pedal cylinder has a diameter of 0.500 cm and each wheel cylinder has a diameter of 0.500 cm and each wheel cylinder has a diameter of 2.50 cm. Calculate the magnitude of the force F2 created at each of the wheel cylinders. So from the problem set, these are the given. So ang atong F1 is equals to 500 Newton or 500 N. Then ang atong cross-sectional area is equals to, cross-sectional area sa F1 is equals to 0.500 cm. So mo ni siya ang diameter of the cylinder. Dayon ang atong F2 mo tong gipangita, since then ang ato ding A2, the cross-sectional area of the double cylinder, diameter cylinder is equals to 2.50 cm. Dayon. Dinin ta sa solution. So, to find the force, we must use the Pascal principles. So, this is the Pascal principles. F1 is equals to A1 is equals to F2 over A2. So, since kanang F2 man lang atong gipangita, so ato siya ipagawa. So, ato siya i-manipulate. So, kani ipagawas na to ang F2, then makakuha na din tani nga equation. F2 is equals to A2 over A1 times F1. Dayon, kani dayon ang atong cross-sectional area sa A2 pi r squared over sa A1 then pi r squared dayon times F1. So, since given naman, so ato lang siya i-distribute. So, ang atong A2 is 1.25 cm squared. Dayon ang A1 is 0.250 cm squared. So, gikuan na siya gi-move. Dayon times 500 Newton or morning N sa atong F1. So, ikuan lang dayon kanang simplify. So, F2 is equals to F2 is equals to 1.25 times 10 raised to the 4th power Newton. So, muna siya ang magnitude of the force created at each of the wheel cylinder. So, since ang F1 is kanang ang diameter niya sa cross-sectional area of the cylinder is 0.500 cm. So, since, and then, ang dayon kanang ang diameter cross-sectional area sa F2 is 2.50 cm. Then, mo din siya ang F2, in which is equals to 1.25 times 10 raised to the 4th power Newton. So, let's proceed to the problem set number 4. Example 4.4 on page 710. Calculating average density. Suppose a 60.0 kilogram woman floats in fresh water with 97.0% of her volume submerged when her lungs are full of air. What is her average density? So, pila daw ang average density sa woman nga nagtimbang og 60 kilogram nga naglutaw sa fresh water. So, these are the given from the problem set. So, R is equals to 97.0%. So, muna siya ang the volume submerged of the woman. Dayon, ang atong density of the water is equals to 10 raised to the 10 cube kilogram over m cube. Then, dayon, ang average density of the woman ang atong gipangita. So, solution. So, to find the average density of the woman, we must use this equation. So, fraction submerged is equals to P object over the density of the water. So, P object is equals to the average density of a woman. Dayon is equals to fraction submerged times the density of the water. So, since given naman ang atong mga value, so kani siya ang fraction submerged is equals to 0.970 since man siya kanang naka-percent man so ato lang siya i-times 100, so i-move na to siya into 1 to 3 pack. So 1 to 3 pack 1 to pack 0.97 ay 970. So muna siya ang atong fraction submerged. Dahil ang atong density of the water is equals to 10 kilogram over m cube, since constant ko naman ang density of the water. Dayon, so simplify lang dayon. So we can now derive the average density of a woman. So is equals to 970 kilogram over meter cube. So mas less ang average density sa woman mas less siya sa diri sa density of the water kay kuan man kanang naglutaw man ang woman. So that's why mas less ang average density sa woman, in which is equals to 970 kilogram over meter cube. So let's proceed to the problem set number 5, example 4.5 on page 714 to 715. Calculating fluid speed through a nozzle. A nozzle with a diameter of 0.500 cm is attached to a garden hose with a radius of 0.900 cm. The flow rate through hose and nozzle is 0.500 liter per second. Calculate the speed of the water in the hose and in the nozzle. So, pangitaon na to ang speed of the water sa hose and sa nozzle. So, muna siya ang given from the problem. So, Q or the flow rate is equals to 0.500 liter per second. Then, ang atong A1 or ang atong cross-sectional area in which kanang into radius is 0.900 cm. Then ang atong A2 in which the cross-sectional area of the centimeter diameter in which is equal to 0.500 cm. Dayon ang atong gipangita is the V1 or the speed of the water in the hose and the V2 or the speed of the water in the nozzle. So, solution. So, first we must get the speed of the water in the hose. So, V1 wait lang. V1 na siya. V1 is equals to Q or flow rate over cross-sectional area. So So para pangitaon ang kuan speed of the water in the hose, so we must use this equation or formula. So it's equals to flow rate over pi r squared. So nganong na ako ano siya is kanang cross sectional area, so kuan siya sa pi r squared. And dayon is equals to, so kuan dayon is substitute, so 0.500 liter per second. So since mo na tong flow rate, dayon 10 raised to the negative 3 power meter cube over r. So nganong kuan nagwonder nga nay kuan ni siya naani siya, so kuan man, so mo ni siya ang kuan kanang density of the water, dayon over ang atong pi, in which 3.14 times 9.00 times 10 raised to the negative 3 meter. So same lang siya po katong nay kuan value sa kuan kay kuan man kanang diameter bitaw centimeter diameter. So therefore ang atong kuan kanang speed of the water in the hose, in which the V1 is equals to 1.96 meter squared. So proceed ta sa kuan letter B, or the kuan the speed of the water in the nozzle. So to get the speed of the water in the nozzle, so we must use the equation of the continuity. So muna siya A1 times V1 is equals to A2 times V2. So since kanang ang kuan man kanang kanang ang speed of the water in the nozzle man ang kanang gipangita, so ato siya ipagawas. So ipagawas na to ang V2, so ato siya i-manipulate kani nga equation. So ana siya ipagawa, so i-manipulate, so muna dayon ang equation natong gamiton. So V2 is equals to A1, or the cross-sectional area, the radius over the cross-sectional area, A2, the centimeter diameter, times V1. So is equals to pi r squared over pi r squared, r2 times V1. So since kanang given naman ang mga kuan mga value nila, so ato lang siya i-substitute. So nga tong A1 or the radius cross-sectional area is equals to 0.900 cm kana siya, centimeter squared, dayon over ang atong A2 or cross-sectional area centimeter diameter is equals to 0.250 cm times ang ato ding V1. So kanina pangita na nato ang V1, so ato siya i-multiply. So, ito siya distribute. So, 1.96 meter per second. Dayon, so, kung din i-simplify, so, therefore, our V2 or the speed of the water in the nozzle is equals to 25.5 meter per second. So, muna siya, muna ang kanang speed of the water in the hose, 1.96 meter per second. Dayon ang speed of the water in the nozzle, in which 25.5 meter per second. And let's proceed to the final or the last problem set, number 6, example 4.7 on page 720 to 721. Calculating pressure, a fire hose nozzle. Fire hoses used in major structural fires have an inside diameter of 6.40 cm on figure 14.33. Suppose such a hose carries a flow of 40.0 liter per second starting at a gauge pressure of 1.62 times 10 raised to the 6th power Newton per meter squared. The hose rises up 10.0 meter along a ladder to a nozzle having an inside diameter of 3.00 cm. What is the pressure in the nozzle? So, these are the given. So, these are the given from the problem. So, ang atong flow rate or the Q is equals to 4.0 liter per second. Then, ang atong cross-sectional area, A1 and A2 is equals to 6.40 cm and 3.3 cm. Then ang atong kanang density or the P1 density of the water is equals to 1.6 the gauge pressure is in which the P1 is equals to 1.622 times 10 raised to the 6th power Newton per meter squared. So, solution. So, we must use the Bernoulli's equation. So, P1 plus 1 half PV subscript 1 squared plus PGH. Then, ang P is equals to P2 plus 1 half PV subscript 2 squared plus PGH2. So, subscript 1 din ang subscript 2. So, pero unahon sa nato ang pagpangita ang V1 and V2. So, since ang atong Q or ang atong flow rate is equals to A1 times V1, so V1 is equals to flow rate over the cross-sectional area A1. So, is equals to Q or the flow rate over pi r squared. So, ang atong flow rate given is 4.0 times 10 raised to the negative 3 power meter per squared. So, over ang atong pi is 314 dayon kuan ang atong r squared is 3.20 times 10 raised to the negative 2 meters. So, nganong nakuha na siya kay kaniman mo ni siya dili sa A1 kanang cross-sectional area. So, we can now kuan sa V1 and V2. So, V1 is equals to 12.4 meter per second. Then, ang atong V2 is equals to 56.6 meter per second. So, nganong nakuha na to siya kay kanang katabi tong last kuan same sa, di ba kay kuan na siya problem set number 6. So, katong same sa problem set number 5. So, same ra ang pagwa sa, so, same ra ni siya pagwa sa kuan V1 and V2. Ano siya. So, now, we must find the P2 or the pressure in the nozzle. So, P2 is equals to, so, kanang sa kanang pangitaon na pressure sa nozzle. So, gamiton na nato ang Bernoulli's equation. So, kani siya, P2 is equals to P1 plus 1 half P times the quantity of V subscript 1 squared over V subscript 2 squared minus the density, gravity, and the height subscript 2 PGH. So, kuan dayon kanang substitute lang dayon. So, ang atong P1 is equals to 1.62. So, kani ang atong P1, the gauge pressure is equals to 1.62 times 10 raised to the 6th power Newton per meter squared plus 1 half. Kani siya 1 half. Then, ang atong kuan times 10, 1,000 kilogram over meter cube times ang atong kuan V1. So, kani siya ang atong V1. So, 12.4 meter per second squared minus ang atong V2 is 56.6 meter per second squared. So, i-substitute lang siya. Then, minus 1,000. Ang atong kuan lang density is equals to 1,000 kilogram per kilogram per meter cube times ang atong constant value sa gravity in which 9.81 meter per second squared times ang height niya is 10.0 meter. So, ikuan lang dayon siya kanang i-substitute. So, therefore, the pressure in the nozzle is equals to 0. So, mo na siya. So, same lang ang kuan, same lang ang value sa pressure kay mura ka lang kuan bitaw sa atmosphere. So, mo na siya. So, therefore, the pressure in the nozzle is equals to 0. So, that would be all. Thank you so much. And to God be all the glory. Bye.